Imagine the biggest laser beam on Earth. Now imagine 192 of them. Now imagine all those lasers focused on a tiny capsule no bigger than a BB.
Man, it's Star Trek and Star Wars and Battlestar Galactica.
Yeah. This isn't a movie set. It's one of the most ambitious science experiments in history. 3.5 billion of your tax dollars at work. It's called the National Ignition Facility, or NIF, part of Lawrence Livermore National Laboratory in California. Inside that little capsule is a bead of frozen hydrogen. The lasers blast the hydrogen atoms so hard they merge, a reaction that releases enormous amounts of energy. It's called fusion. Stars do it all the time, but at NIF, they're trying to control that reaction here on Earth to generate clean, limitless power.
There are no global warming gases. There are no proliferation risks associated with this. You wouldn't have to go to the Mideast or wherever to get our fuel that drives our civilization.
Ed Moses is the director of NIF.
And you're saying we're a year away from this?
Well, we're a year away from scientific feasibility of it, proving that it could work. We're approximately a decade away of proving this at commercial scale.
NIF invited Sunday morning into the control room to watch an actual laser shot. The first time they've ever let TV cameras inside.
Countdown started at T-minus 255 seconds.
A NIF shot is modeled on a NASA launch. The shot director polls his stations.
Beam control. Beam control ready. GDC is ready. Target area is ready.
There's a countdown.
5, 4, 3, 2, 1, shot.
And then... nothing. No explosion, no roar. All the action takes place behind 5-foot concrete doors and in the computers.
So how did that shot go?
It went very well.
Well, maybe. But 3 years after construction was completed, NIF still hasn't achieved the promise of its own middle name, ignition. That's the magical moment when they get more energy out of a laser shot than they put in. And if NIF does attain ignition, laser fusion still won't be able to power a city until a plant can fire hundreds of shots a minute.
What's so nice about the scaling from this to an energy program is you just have to do it more often. And we're very confident that can happen.
Not everyone is so confident.
We'll see pigs fly before we see ignition at the National Ignition Facility.
Mary Leah Kelly runs a California watchdog organization called Tri-Valley Cares. But it should be called Tri-Valley Doesn't Care for NIF. She can't stand the costs.
When you add the construction-related research and development monies, U.S. taxpayers have already invested more than $7 billion in the National Ignition Facility.
She hates that it uses radioactive material.
The target is a 50-50 mix of deuterium, which is heavy hydrogen, and tritium, which is radioactive hydrogen. And so there'll be a lot of emissions.
Ed Moses says that's nonsense.
There's no danger to the public whatsoever. We all work here. If we thought it was dangerous, we certainly wouldn't be here.
She hates that it keeps missing deadlines.
The National Ignition Facility promised ignition in 2010. 2010 has passed and it did not happen.
This is grand challenge science. You know, the Wright brothers, had they flown their plane a week later, would we care today?
Above all, Kelly is convinced that laser fusion just won't work.
That ignition is highly unlikely, but nothing is impossible. And they're trying to live in that little tiny region between highly unlikely and impossible.
Not surprisingly, Ed Moses disagrees.
Are we breaking any rules of physics? You know, are we breaking any of the laws of thermodynamics or anything like that? And we are not. Otherwise, we wouldn't do it.
In the battle against the skeptics, NIF just won an important round. A few weeks ago, one of NIF's test shots blasted the capsule with a record-breaking 1.9 megajoules and generated 1,000 times more power than there is in the entire United States electrical grid. And they say that's enough power to trigger ignition in a shot later this year.
Because if you think about a world free of the need of carbon, free of the need of geopolitics and energy demands, and one that also should change the whole view of pollution and also the whole view of global climate. What more could you ask for? So that's what I'm thinking about all the time.
5,